Okay, well, good afternoon, everyone. This workshop, Learn SQL with Datasets, will run for the next 45 minutes, and I've prepared a very detailed handout, which is this document right here, bit.ly/dataset-SQL. There's a link in the chat there, and I'm also going to have the little post-it note up on my screen throughout, so that you can find that link if you need to. I will be working entirely from that, so I very strongly recommend opening up that document. I also like to do Q&A for these workshops in the document itself. So that document is set so you can edit it. You can add your own notes and screenshots as you go along, but you can also drop questions into the questions sections. There's a Q&A area that I've set up after each of the sections in the tutorial. And I'm very, very keen on questions and comments. And like I said, if you want to add extra notes to the document as well, that would be fantastic. This will turn into a handout that we can refer to later on once the session is ended. So my name is Simon Willison. I am the creator of Datasette, the software I'll be showing together. And I built Datasette based on experiences I had originally at the Guardian newspaper in London, working with journalists, publishing data behind stories, and trying to figure out how can we better do analysis against these sort of news-sized data sets, stuff that doesn't really fit in an Excel spreadsheet, but also doesn't necessarily need a giant data warehouse to crunch through it. And I've got a fun example of the kind of data I'm talking about that we'll work through today. So rather than getting stuck straight into a whole spiel about what Dataset is, I think we should dive straight in and start using it as an using the example and using that to sort of both illustrate what the software does and to start exploring databases and SQL. So this right here is a Dataset instance I launched this morning with a database about members of the United States Congress. This is based on this wonderful project that's been running on GitHub for nearly a decade now, where a team have been gathering information about current and historical senators and congresspeople and presidents and vice presidents and making that available as structured data. So it's kind of cool. You can grab this as CSV or JSON right now to start exploring it. But I've loaded into Datasette so that we can start using that software to analyze and explore that data. So before we dive straight into the demo, the most important thing to understand about databases is that databases consist of tables, and tables are pretty much what you would expect a table to be. So this is a table right here of legislators, and the table has rows and columns. It's very much like a spreadsheet, except that spreadsheets can have formatting and you can merge cells together and do things like that. With a database table, it's just rows and columns. That's all that you get. So here we have a table of data about legislators. These are individual human beings who have at some point been a senator or a congressperson. This data goes all the way back to, well, actually, let's do sort ascending. It goes, oh, we've got senators there that don't have names, that don't have birth dates. If I say show not, there we go. Our earliest representative with a birth date was born in April 1721. So you can see that this is a pretty extensive data set about those members of Congress. So we have right here in this database, I think, 6 tables. And those 6 tables are all pulled from this Congressional Legislators project on GitHub. And when we look at these, each table has a bunch of rows and a bunch of columns. And so the most interesting table is this one called Legislator Terms. It has 44,000 rows in it because it's got a record for every time a human being was elected or was appointed as the senator from Delaware from a start date to an end date for a certain political party. But we're going to start off by looking at something simpler just to start, just because it's easier to start illustrating things. We're going to start out by looking at executives. So that's human beings who have been either president or vice president, and there's 80 of those, and executive terms. Executive terms, this is a table that tells us that George Washington was president from 1789 to 1793, and then again from 1793 to 1797. And we've got a record in this table, 129 records total, for every time a human being was either a president or a vice president. Here's John Adams as a vice president at the same time as George Washington. And we can do some relatively, the things you might expect to be able to do with this. So we can sort by different columns. Let's sort descending by the start date of their term. Now we can see there's Joseph Biden and Kamala Harris. We can also, where this stuff gets a lot more interesting is when we start looking at things like the relationships between tables. You'll notice that in this row here, we've got Joseph Biden as president, but Joseph Biden right here is itself a hyperlink. This is a link that you can click, and it takes you through to this page about Joseph Biden. So Joseph Biden only has one link from other tables, and that's the link that we just saw there. But generally what this is illustrating is a key idea behind relational databases is that you can have relationships between different rows. This is, I guess, Excel has a sort of VLOOKUP mechanism, which is a little bit similar to this, but this is really the heart of where databases get interesting. You can have rows that relate to other rows, which means that you can represent all kinds of complex relationships between different entities in the world. So I'm going to take a quick pause now before we move on to the next session to see if there are any questions so far. Again, you can drop questions into the Hopin chat as well, or put them in this document. Of course, if you put them in the document, I have to scroll down and see if I can find them. So Datasette lets you explore tables. You can sort things and scroll through them and try and get an idea for the data that way. But it also has a feature called faceting, which is an extremely powerful way of taking one of these database tables and beginning to get an idea for what kind of trends of data there are in there. So right here, it says suggested facets. There's type and party. So I'm going to click type. And that shows me that there are 68 records for presidents and 61 records for vice presidents. If I click party, we can see that I had never heard of the Democratic-Republican Party, but apparently they've had 15, there have been 15 terms where they've held the presidency or vice presidency. And actually, if we click on vice president here, now I'm looking at just the 61 rows here where it's showing me a vice presidential term. And for that, the Democratic Republicans have had 8 instances. So as you can see, faceting serves 2 purposes. It gives you these summaries about the data that you're looking at. It tells me that of the 129 terms, 53 were Republican, 40 were Democratic, and so on. And it also gives you links to navigate and start filtering down that data. I can look at just the presidents and get back 68 records. And now these numbers have updated to reflect that too. So against a table like this one with only 129 rows in, that's sort of useful, but it's not necessarily a sort of a deal-breaking advance. But when you look at something like legislator terms, that's got 44,000 rows in it. Scrolling through this and clicking next page and trying to get your head around how that works is going to take a very long time. But if we instead start applying these facets, if we say, okay, show me type, and let's do the suggested facets show you things that will get you a small number of results. For state, we can get faceting by clicking on the cog here. So I can say I want to facet by state. And now I can see all of the states. So I can see New York has had the most legislator terms in our database. Let's just look at those. And of those, we're going to look at the 101 terms that were a senator. And there's Aaron Burr as the first senator from New York back in 1791. Again, if I facet by party, I can see that the Republican Party has had 43 of those senatorial terms in the state of New York. The Democrats have had 36. The pro-administration party has just one of those. That was Philip Schuyler in 1789. So we started out here with 45,000 rows in a table and not much of an idea about what we were going to do next. And just by starting to click on these facets, by starting to slice and dice the data by state and by party and so on, we start finding out facts about our data, like the fact that Democrats have held 20,000 legislative terms, Republicans have held 19,000 over the course of history since the 1790s. That's an interesting thing that we've now learned just from starting to explore and browse through this data. So, I've got a couple of exercises which I will pause for the moment to encourage people to try this out yourself. So these are two exercises to try it against that executive terms table. You can follow the link here to get to the table. Try applying the type, state, and party facets to it first of all, and then use those to find just Republican senators from North Carolina. North Carolina, I'll put in a note here, is NC. So if you try that out on your own machines, that should give you should be able to start slicing and dicing that data pretty easily. I'm going to pause as well for people to try that out, and also if anyone has questions, you can pop them in this section down here. Okay. So the next feature I want to dive into is one that you've started using already. When you were applying facets, you may have noticed that these boxes appear at the top of the screen. So it's now saying 4,000 rows where state equals NY, and there's a box where it says state equals NY. These are what we call filters, and these are ways, again, of filtering down that data. And so I can click around in the facets, or I can change things in here directly. If I change that to CA and click apply, it'll show me the rows from California. If I add in here party Republican, oh, I misspelt Republican, so I get back 0 results. But if I say Republican there, now I'm seeing the 953 rows that show me a Republican in the state of California. And the faceting interface continues to work. If I click type here, I can now use, instead of typing things in up in these boxes, I can say actually just show me the senators from California. We've got 36 senatorial terms there. And oh, actually, here's something I'm going to try. What happens if I facet by legislator ID? So if I facet by legislator ID, I can see that Hiram Johnson has had the most terms as a senator in California. He's been senator for 5 terms, all of those in the Republican Party. And when was that? Oh, that was back in 18. No, let's click on that one right now. So yeah, Hiram Johnson, 1917 through 1941, he was a senator from California. So this is showing how this filter interface here and the ability to faceting, these are compatible things. You can facet to build filters. You can filter to narrow down the data that you want to record with a facet. A very important feature of this software is that anything that you can see on the screen, you can also share a link to, and you can bookmark, and you can hit the back button in your browser to go backwards and forwards. You can look through your browser history to see what you've been doing, but you can also copy and paste those links. So I'm going to copy and paste this, and I'm going to stick this into the document. Hiram, that was Hiram Johnson, wasn't it? Has the most senatorial terms in CA. And the idea here, this is really designed for collaboration. The idea is that if you're in a newsroom environment and you're trying to dig around in one of these huge data sets and find the interesting stuff, anytime you find an interesting view onto it, like, for example, this view here, which is showing me the senators from California, the Republican senators of California who've served the most terms. That's now something I can share a link to and stick it in Slack or email to one of my coworkers as a way for them to see what I'm seeing on the screen. So if anyone has dug, if you're digging around in the data right now, I'm going to leave a gap for people to paste in links to anything interesting that they found in this table or in any of the other tables that you've got that are available here. I'm actually going to ditch Republican from this. So Hiram Johnson was the most prolific Republican, but Dianne Feinstein has had 6 terms as a Democratic senator for the state of California. Actually, if I get rid of senator as well, wow, but George Miller had 20 terms as in the House of Representatives. Oh, and this is interesting. When we browse through this, we can see that his district changed. He was in District 7 for the first 19 of those, but then his final term, he served in District 11, presumably from redistricting. So that's an example of another example of the kinds of things that just start jumping out at you once you've got a way of slicing and dicing and navigating through that data. So I'm going to move on to another sort of, oh, and here's a link that somebody's just added. Let's see what this one is. So this is party affiliations is not blank, sorted by party affiliations. So where's, oh, this is a bug, to be honest. So when I imported the data into this demo, I tried to break some of those things out into separate tables, and it looks like I missed one. Party affiliations here is showing the sort of raw JSON data that came in from the data I imported, which this would be a lot more useful if it was split into a separate table, so I could start doing things like show me. I'd love to see legislators who have more than one party affiliation, which is kind of what we're seeing right here, because there's something very interesting about just highlighting like people from California who started in one party and switched to another. I imagine people who switched to independent would be interesting. And actually that we can do. We can say party affiliations contains independent, and that shows me just the ones that have independent in their list of affiliations. I'd love to know more. Look at this one here. Justin Amash went Republican, then Independent, then Libertarian. I was not aware of that. So yeah, there's so much stuff that just starts jumping out at you once you start navigating through this data. So the next, another philosophy that Dataset has is anything that you can see on screen, you should be able to link to it, but you should also be able to export it back out again. So let's go back to the executive terms. Let's look at just the Whigs. These are the 6 times a member of the Whig Party has been. Oh, look at this. You can have a Howard succession. That's super interesting. But here I've got 6 Whigs, and I can export that data in a bunch of different formats. If I click on CSV here, I can get it out as CSV data. And actually, there's an advanced option to download that file. So if I click that, my browser gives me the option to save that to disk, or I can copy and paste it out or use the browser save feature too. You can get it as JSON. So if you're a software engineer, this gives you the ability to load that into other software, into Python or JavaScript, and build your own visualization things against it. And then this version of Dataset here is running a plugin that adds something called Copyable, which gives you the ability to copy and paste that data out. So if I hit copy to clipboard here, and then open up, I'm going to open up Numbers, because I happen to have it running on this machine. And this will work with Google Sheets and Excel as well. If I select the top cell up there and hit paste, that pastes in that data directly into my spreadsheet. Actually, let's do something bigger. Let's do all of the legislator terms for Arizona. Now, this is actually there's a bit of a catch here. In this case, if you copy the data, you only get the first 100 rows, which is a limitation of how that plugin works. And it's something I should try and fix, I think, because being able to copy and paste data around like this, I find to be incredibly useful. If you want all 526 of these, the way to do that is with the Stream All Rows option down here. So if I click that, this gives me back all of that data on that page for, in this case, all of the, where was that? All of the legislator terms in the state of Arizona. So you've got CSV export and JSON export, which is export. Those are useful. The other thing you can do is you can grab the entire database file itself. So if we go back up to the page for the whole database, and this page here, at the very bottom, there's a link to download the SQLite database file. If I click that, my browser will offer to save that file to disk. You'll see it's quite small, right? Despite having, what is this, 59,000 rows across 6 different tables, it's only a 5.2 megabyte file. So a lot of these things are actually very easy to grab copies of, to forward around, to keep. That's something which I'm personally really interested in, is the idea of sharing databases like this one as these SQLite database files, because it's a really flexible format for like bundling up a whole bunch of different data. It's almost like a zip file full of CSVs, but it's a single file that you can put this data in and share with other people. So yeah, any Dataset instance that's sharing data like this, there's probably an option to download that database file itself. Okay, I've got one more. So a couple of exercises to enforce that. You can try downloading a CSV file of the Democratic vice presidents in the 1800s. Oh, I skipped over that when I was looking at filters. So let's do this exercise now. Let's do Democratic vice presidents in the 1800s. So for that, we can go to executive terms, filter by party, and ask for just Democratic presidents. I wonder what the difference between Democratic and Democrat is. I think that's a data entry problem. Look at this. Unless the party changed its name back in 1997 and I didn't hear about it, which is perfectly possible. So in that case, we need to do something a bit smarter here. We need to say where party is in, and then put Democratic, comma, Democrat. And if I do that, that gives me back both of those values. I'm going to throw that in as a quick example here. Both Democratic and Democrat executive terms. So I'm glad I spotted that, because that's not something I'd realized about this data. So what did I want? I wanted all of the vice presidents from the Democratic Party, and then I want to do who were active in the 19th century. The way we can do that is we can say where start starts with, and then put 18. So if I do this, that's now filtered down to just the 1800s worth of Democratic vice presidents. And I can hit advanced, download file, export CSV to get back that, to export that CSV file of Democrats, of Democratic vice presidents from the 19th century. I'll stick a link to that in here. Oh, I'll stick a link to that in here as well. And again, if we hit the copyable link up here, we can copy and paste just those vice presidents from the 19th. Oh, that was interesting. I think there's a weird numbers bug where sometimes it pastes things twice. Oh well, but that's very surprising. But yeah, so you can copy and paste into Google Sheets or Excel in that way. So one last sort of core feature of Dataset before we move into talking about SQL. Dataset has a plugins mechanism for adding additional features. You've already seen one plugin, the copyable link that I showed you was provided by a plugin. But the other thing that plugins can do is visualization. So the offices table here shows every legislator's, these are their official offices that they maintain. And we can do things like facet by this to see that John Kennedy and Rick Scott have the most offices. I'll click on Rick Scott and see that he's got offices. He's got 9 offices throughout Florida. And as you can see, the data is now showing up on a map. The way this plugin works, the plugin is called Dataset Cluster Map. And all it does is it looks for a latitude and a longitude column. And if it finds them, it puts the data on a map and zooms in so that you can see those markers. So this right here is showing me a map of every legislative office that's maintained by Rick Scott. If I go back to this page, I can click on load all and load in every single one of those markers. So we've now got, I was looking at this earlier, and something I found fascinating is if you zoom in down here, there are no representative offices in Puerto Rico, but there are, the United States Virgin Islands does have one here. This is Stacy Plaskett, who's a representative who covers the Virgin Islands. So this is something I really like about having these kinds of visualizations, is the fact that there is, for example, and also the fact that there is one office down here in is this Guam? I think this is Guam. What state code is AS? Because hang on, let's do. I'm going to ask it for where state equals AS. No, I think AS is not a state. I think AS is where on earth is Pago Pago? American Samoa. American Samoa. So AS is not an official state code. But it's being used here to represent American Samoa, and that's the single office in American Samoa, which is which representative is that one? Hang on. Which is Amua Amata Radewagen is the legislator from there. And again, we had a table with 1,192 rows in it. If we scrolled through that one at a time, we could maybe figure out something interesting. But just by putting that data on a map, we instantly see things jump out at us. We see, okay, these are the outliers. These are the interesting corners of the world that we can dive in and try and understand what's happening there. So anytime you have data with latitudes and longitudes, especially, this tool is so useful. Like if you go to the datasette.io website, I link to a demo that lists all 33,000 power plants around the world, and it puts those on a map. We can load those all up. And even just here, just with these 33,000 power plants, you start noticing interesting things straight away. Right down here, there are 2 power plants in Antarctica, which are listed in this database of power plants. And I can zoom in on those. Oh, I need to wait for it to finish loading. If I zoom in there, I can see that McMurdo Station in Antarctica has a oil generator, and it also has a wind turbine. And that's from all of those, 33,000 records, that one jumps straight out, because when you look at the data on a map, there's something interesting down there at the south end of the map. I'll stick a link to that one in here too. Okay, so does anyone have any questions before we move on to talking about SQL? I've tried to give a reasonably thorough tour of the sort of key features that Dataset offers once you've got data loaded into it here. Okay, in that case, let's talk about SQL. So the secret sauce of Dataset is that it's running on top of a database. It's running on top of a database called SQLite. And SQLite is a fascinating piece of technology. It's about 20 years old now, and it claims to be the world's most, where does it say this? It claims to be the most widely used database engine in the world. It's the most used database engine in the world. And that's because SQLite was originally designed to work inside other software. There's a SQLite database on my watch that counts my steps. My iPhone has dozens of SQLite database. My Mac has hundreds as well. Anytime somebody's building an application for a desktop computer or a mobile phone, there's a good chance that they will use SQLite as the underlying database. And with Dataset, what I've been doing is exploring what happens when you put those databases online and let people have that web-based interface for exploring them. So SQLite is a really good way to start learning SQL itself. SQL is this language for running queries against databases. And unfortunately, there are as many flavors of SQL as there are databases. MySQL and Postgres and Oracle all speak it slightly differently. The SQLite flavor tries to be a sort of mix between all of them. So I find if you're learning SQL with SQLite, it'll probably help. It'll probably work in other databases as well. So for this tutorial, I've stuck with a subset that's likely to work everywhere else. And so with Datasette, the key to using Datasette to learn SQL is knowing that anytime you can see data in Datasette, you can click this View and Edit SQL link, and it'll show you the underlying SQL query that was used for that page. You can click this Format SQL button here to expand that out and make it tidier. So here, this table right here was this quite complicated statement. I've got select a bunch of things from the executive terms table, and then I've got a bunch of where clauses. I'm saying where the party is either P0 or P1, and the start is like P2, and the type is P3. And those variables, P0, 1, 2, and 3, are defined down here. So I'm saying P0 is Democratic, P1 is Democrat, P2 is that 18 and then a percentage, and then P3 is the vice president. What's fun about this is that you can start editing it. So first I'm going to change this to say select star, which is a way of saying give me all of the columns, and that gives me back everything. But if I just wanted the start and end dates, I could say select start, end, and now I get back just those starts and ends. I can remove bits. So if I don't care about that party filter anymore, I can remove that. So I got an error here, which says near and syntax error. And that's because SQL doesn't like you to say where and, you have to say where something and then split those things with an and. So I've got where start like P2 and type equals P3. But I can also change these parameters. Let's look at the president instead of the vice president. And actually we'll do star here so we can see what's going on. And so now I've modified just that parameter, and now I'm seeing those records for type of pres as opposed to for type of vice pres. I'm going to remove this, and now I'm just seeing presidents and vice presidents that were active in the 18th century because of this where start like P2. Going back to this one, this is the one that's just presidents. You don't have to use these parameters. You can also put single quoted strings in for values. So I'm going to say where type equals pres just as a string. And if I do that, I get back all of those president rows. Oh, and we've got an order by here. I'm going to modify that. Let's say order by start desk. So desk means descending. That gave me 2021 as the top row. If I remove desk, I get everything ordered from 1789 upwards. And then finally, there's this limit, which you can use to control how many rows you get back. So without the limit, I get back everything, which is 68. If I add limit 10, I'll get back just those first 10 rows in that table. So an important thing that you can do here is if you're trying to learn how to do something in SQL, with Datasette, you can start by doing it with this interface here. So I can say, you know what, I just want things where the how was a succession and the party was the Whigs. And then if I click View and Edit SQL, it'll show me what that query looked like. So in this case, it was where how equals P0 and party equals P1. But this gets more interesting when you're looking at some of the more complicated operations. We've seen that start one already, where I said start. Let's do start ends with 0. So this is giving me back everything where it ended on, like in the 1730, 20. No, actually, sorry, my mistake. Start ends with 0 is giving me everything where the day of the month ended in a 0. That's a bit bizarre. Tell you what, I'm going to do start contains, and I'm going to say -01 dash, which should give me back everything that happened in January, which it did there. But then if I click View and Edit SQL, I can see that the way that query looks is where start like P0, and P0 here is %-01-%. So that this is a useful tool for basically building SQL queries visually using the filtering interface, but then extracting those, but then turning that into a query that you can see how the SQL works and start modifying it further yourself. So I've got a set of exercises here for building some of those queries. My suggestion is to start with this query here. This is the query that's showing me. This query is showing me every legislator where gender is F, so every female legislator in that database. And so we can start working through this. Firstly, let's have back just those ID and name columns. I can delete those there. And here I've got a near from syntax error. It's not the most useful error message. The reason there is that there's a comma here and there shouldn't be. It likes you to have commas between the things you're selecting, but not at the end. So I get rid of that. So here's the list of all. This is just 101 female legislators. I'm going to try sorting it by name instead of by ID. So I'll change the order by to name. And now I'm seeing them alphabetically ordered. I'm going to look at male legislators instead of female by changing this F here to M. So now we're seeing that alphabetical list of male legislators. And finally, I'm going to use, instead of this select ID, name, I'm going to go back to using select star. So now I'm seeing select star from legislators where the gender is M for male, ordered alphabetically by name. And I'm seeing the first 101 of those. I'll get rid of that. So a limitation of Dataset is it will return a maximum of 1,000 rows. So here it's saying at the top, it's warning you that this query returned more than 1,000 rows, which means that you've only got 1,000 on this page. So if you need to get more than the first 1,000, you're going to have to start thinking about paginating those results, which is out of scope, I think, for today's tutorial. So we've now talked about the basics of starting to work with SQL, with starting to write those different select and where and order bys and so forth. I also wanted to emphasize this idea of these named parameters, the :P0 and the :P1 that we saw earlier. This is a safety feature, actually. It's there is a security hole in some database, in some applications called a SQL injection vulnerability, which you can read about on Wikipedia. But basically, it's a problem that comes up when when other people can add their own complex SQL logic to the SQL that you're building. The way to avoid that is with these parameters. You can, when you say :P0, it takes the value from there and it wraps it safely in quotation marks for you, so that it can't leak out into the rest of the query. But the way Dataset works, these are just the things from the query here. So I can change their names. If I want to say start like century and type like type, if I run that, it renames those form fields. So now I can put century as that and type as pres. And now this is a little bit more readable. This is instead of P0 and P1, it's saying century and type. The crucial thing here is this is designed for sharing with other people. So you can actually hide the SQL query up here. And then if you have coworkers who don't know SQL, but need to be able to interact with that database, you can construct these queries for them. Let's stick this in, link to the hide. Yeah, you can then share that link with them, and they don't have to know how to use SQL. They just have to know how to change these values here. Actually, this one here is not so good because they have to know to put a percentage in. I'm going to change that to century like this. So this is a little trick you can use where I'm actually adding a percentage on there to make that form more readable for those people. So hang on, better. But now you can imagine how you might have other reporters who need ways of querying this data, and you can essentially build entire applications that exist as bookmarks. They exist as links that you share around, and people stick on Slack, stick in documents. People can click on those bookmarks and use them to look at presidents rather than vice presidents, or whatever it is that they want to do. And it's in sort of self-service manner. And if you share it with somebody who knows SQL, they can click show and start modifying that query and build their own custom applications on top of that. Notably, this works for visualizations as well. So if I wanted here's what I'm going to do. I'm going to facet by state, select a state, view and edit SQL, and change this to state. So what I can do here is essentially build this little thing, which this is a map of all of the congressional offices in a specific state. So I can now send a coworker here, and if they want to see Rhode Island, they can put RI in here, and now they're seeing just those in Rhode Island. So this is so I just essentially created a custom application for my newsroom by clicking around a tiny bit and copying and pasting a URL. And I feel like the potential of this is pretty enormous. The idea that you can build custom reporting applications and dashboards just through clicking a few links and then copying and pasting a URL, I think it's really exciting. I'm really hoping to promote this as a way for both for internal collaboration within newsrooms and also for publishing news interactives and things that members of the public can interact with as well. So we talked about the SQL-like query a little bit. We were looking at, when we wanted to look at executive terms in the 18th century, we did that using where start starts with 18. And we could see that actually got turned by Datasette into this 18% here. And this is a SQL-like query is a very simple way of running advanced sort of wildcard queries against these text fields. And it has a couple of things it can do. You can use a percentage to say any characters you like. Let's try percent the other side. And now we should be seeing things where the start date, there aren't any on the 18th of the month. Here we go. This is everything where the start date was on the 20th of the month because the percent matches things beforehand. And you can also use underscores. So I'm going to say everything where it's in February using underscore, 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 hyphen, 02, hyphen, underscore, underscore. Why didn't that work? Oh, because nobody ever starts the term in February. That's why. I'll say January, which is going to be everyone's. This isn't a particularly interesting demo. But you can see that, again, this is doing a wildcard where each of those underscores matches a character. So this is 4 characters, then hyphen 01 hyphen, and then 2 characters at the end. So if you want to try that out for yourself, you can try using a query to find presidential terms that occurred in the 90s of any century. And that should be possible using a combination of the underscore and the percentage sign there. And I'm going to jump straight ahead because I'm cautious of time, and I really want to talk about SQL joins. This is where we start getting into the more advanced areas of SQL. And what we've looked at so far, it's been relatively straightforward. You select some columns from a table, and you apply some filters to filter that down, and you can then order them. What we're going to do now, though, is we're going to look at the problem of joining data from 2 tables together. So this table right here, you'll notice that this very conveniently has an executive ID, which is 1, 2, 3, etc. But it turns that into a hyperlink. It shows you that this was George Washington and this was Thomas Jefferson. But when we click View and Edit SQL, that goes away. We're now just seeing executive ID of 1, 2, 3, 4, 5. Much less useful. It means that if we want to know who number 4 was, we can do that by going to Legislators and then looking at executives and then saying, show me the one where the ID equals 4, and that's Aaron Burr. But that's a lot of steps, right? This is it would be much more convenient if we could see the name of those legislators right there. And we can do that using a join. So what I'm going to do here is I'm going to start by doing executive terms.star, executives.star. From executive terms, join executives on executives.id equals executive terms.executive. ID. And I'm going to get rid of this stuff. So what's happened here is we know that we've got an executive ID in our executive terms table, which corresponds to the ID column in the executives table. And so we can join those two things together like this, and then run a query that returns all of that data combined, which is, to be honest, a little bit much. What I'm going to do instead is I'm going to say, I just want the start and end of the term and the name of the, actually, I'm going to do the type too. So I want the start, end, type, and I want the name of that executive. And now we're seeing useful data, right? This is showing me that George Washington was president from here to here, and John Adams was vice president from here to here. And you know, this is the kind of data that I want to be working with, which again, I can export out as CSV and JSON and all of those kinds of things. So did I have an example? I'll do. There's that join example. And where these joins get really exciting is when you start taking data from entirely different sources and combining it together yourself. I run a Dataset instance with all of the COVID numbers that are published by the LA Times, the New York Times, and a few other publications. And the New York Times are publishing COVID data for counties, where they say the number of cases, the number of deaths that have occurred in different counties around the United States. This page isn't loading, which is frustrating. I will leave that running in the background and see if that loads. But the thing that I ended up doing there was pulling in county population information from the US Census into a separate table, and then joining those two tables together. So I could see what's the number of cases per head of population for those different counties. So here we go. This is showing me that Loving County in Texas has the worst cases per million of every county. Although if you look, it's because their population is 169 people. And oh my goodness, 164 cases. So almost everyone in Loving County, Texas has had a case of COVID at this point. But yeah, this is, if you scroll to the bottom of this page, this is showing a more complicated SQL query that's joining data from the New York Times with data from the US Census, and then using that to calculate the deaths per million using a mathematical formula. So once you've got that ability to join data, you can start doing some very sophisticated things with it. Another advanced SQL technique, I've already shown you examples of facets in Datasets. So hitting a column, selecting facet by this, and seeing these counts down the side. And that's using an underlying SQL query called a group by. So in this case, we want to see the number of times each party has had a presidential term. And we can do that using a query. We say we want party, and then the count of the number of times that appears from this grouped by party. And I'm cautious of time, so I won't dive into that in too much more detail. I'm going to skip these last two sections so we can move to questions. But yeah, so this is honestly, of all of the things to learn in SQL, if you can learn basic filtering and then gain the ability to do counts and group bys, this is where all of that data starts making sense, and you start being able to assemble these different, pull numbers and figures and facts out of these database tables. And Datasette will save you a bunch of time with that by giving you a sort of interface to do it. But really, if you want to learn SQL, learning how to do counts and group bys is a really good way to do that. If you want to try this out yourself, you're welcome to play with any of the public demos that I have running. But you can also use Datasette for your own data. The easiest way to do that, if you have a Mac, is to download the Datasette desktop application, which looks like this. And this is essentially Datasette running just locally on your own computer, and it lets you do things like import CSV files, open them in the Datasette interface, load in your own CSV data, and start joining and manipulating data that way. So that's the easiest to install. If you're not using a Mac, you can use, but you know how to use Python, you can pip install Datasette. That's a universal way of getting it to work on Windows and Mac as well. I'm going to change that to Windows track. And then I've also got some links through to further documentation on the Datasette website for what to do there. So I'm going to skip down to the Q&A here. So if you have any questions, please put them at the bottom of the document. And there's a question here. It says, I have a dataset with over 160 million rows. My home computer can't handle that. Can Datasette handle it? So my rule of thumb is that on my laptop, anything up to about 10 gigabytes of data will work just fine in Datasette. And that's because it's built on top of SQLite, which is an extremely fast and efficient form of database. So 160 million rows would very likely work. The only time it wouldn't is if they're giant rows. If each one of them's got like a full set of, like if it's like a page of a PDF or something, you might run into trouble. But I've used Datasette quite happily against hundreds of millions of rows just running on my laptop, and it works great. There's additional steps needed to import that data, but certainly once you've got it in there, that's a comfortable size of data to use. I think if you're over 1 billion rows of data, you might be able to get Datasette to work if you're very patient, but that's where you probably want to start looking at a data warehouse of some sort, something like Snowflake or Presto or one of those products. Again, one of my goals with Datasette is to take the kind of stuff that's usually only available to you if you have a data warehouse and turn it into something that you can just run on a laptop, right? If you're working in news, billion row data sets are quite rare. Data sets with tens of thousands or hundreds of thousands of rows show up all the time, and those are just fine running on a laptop or running on a very cheap server. The hosted demos that I've shown you mostly only cost $3 or $4 a month to run because I'm deploying them to places like Google Cloud Run, which are very inexpensive for low traffic websites. Okay, so I think we are, I just realized I'd missed the chat questions in here. Datasette is free, it is open source. There are no limits on usage at all. It's under a Apache open source license. There's no non-commercial limits, nothing like that. And the reason I built it like that is if I stop maintaining it, or if I want this to keep working for hundreds of years, right? I don't want newsrooms to take a risk on my software and then my company goes out of business and they don't have access to it anymore. I think that actively harms the news industry. So yes, it's free. It will always be free. It will always be open source. I have ideas to build commercial offerings around it, but those will be like you pay money to have it hosted for you. You'll always be able to run it yourself. And that's fundamental to the project, I think. Can you relate between which representative maintains the highest number of offices? Yes. I'm going to copy this down. I will add rather than figure that out right now, I'm going to add that to the document later on because I'll need to do a little bit of figuring out to work out how to do that. But this is exactly the kind of questions that you can start answering here. So yeah, and is Datasette hosted in the cloud or locally on desktop? The answer is both. You can host it in the cloud yourself if you have the means to do so. I'm working on a paid hosted version. If you're interested in that, please reach out to me. I'm always keen to have new beta testers for it. And yeah, there are multiple ways that you can run it on your own computer as well. I haven't got it running on a mobile phone yet. I think it's possible. I'd love to be able to run Datasette on an iPhone or an Android, but that's way outside of my abilities at the moment. Okay, so I think we are out of time. I am always keen to talk to people about this stuff. If you go to the Datasette website, there's a link to sign up for office hours for in-person conversations. So you can basically use Calendly to grab a slot with me on a Friday for a one-to-one conversation about this. I'm very active on Twitter. I'm active on the GitHub issues for Datasette. The problem with open source software is no one ever tells you that they're using it. So I am absolutely desperate for feedback. If you want to have a conversation about what you're doing with this or what you might want to do with this, I guarantee you I would find that conversation enormously valuable. So with that, thank you so much for coming along. The document here will stay available to you. I'll be writing this up as a formal tutorial as well. And yeah, if you want more information about Dataset, please check out the Dataset website, dataset.io. So thank you very much and enjoy the rest of the conference.